Most scientists believe in the Big Bang Theory, that our universe started with an explosion from a point. There is some empirical evidence for this, such as the 3-degree Kelvin background microwave radiation, but there are a number of problems with the Big Bang Theory and the universe as we see it. The first problem with the Big Bang Theory is that it requires a starting point, t equals 0, t being time. Having a starting point is like having a god. What was there before the Big Bang? The other problem with the universe, with our universe as we see it, is it consists mainly of matter. Whereas for every particle there is an antiparticle. For example, the antiparticle of a proton is an antiproton. For an electron it is a positron, and so on. Why does the universe consist mostly of matter only? Especially if it started from a so-called quantum fluctuation. There should be equal amounts of matter and antimatter. The main problem with trying to explain our universe is the fact that its expansion rate seems to be increasing. Instead of slowing down, which it should be doing, because the galaxies would eventually start pulling on each other gravitationally, slowing down the rate of expansion. Instead of slowing down, the expansion rate of our universe is increasing. To get around this, scientists have postulated that the universe consists of 68% of dark energy, 27% of dark matter, and only 5% of matter. The 5% is what we see, or can see. Dark energy is postulated simply to try to explain this fact. It is hypothetical. No one has observed it. It is an ether. It is like a fifth force, like an anti-gravitational force, which is pushing the galaxies further and further apart, instead of allowing the gravitational pull to actually pull them back in towards each other. Dr. George Christos, a theoretical particle physicist, has come up with some ideas of how we might be able to get around the need for dark energy. He has put forward the idea that maybe our universe is just an exploding black hole which existed in our pre-existing universe. As particles get pulled into a black hole, they run out of quantum states to all be able to stay in there. There are two types of particles: fermions, particles of half-integral spin, like the proton, neutron, and electron, and bosons, particles of integral spin, like the photon. Most particles are actually fermions, other than the photon and the gauge particles, like the gluon. Most of the matter consists of fermions, and inside the black hole, most are probably just quarks and electrons. Fermions have the special property that they cannot be in the same quantum state. This is the so-called Fermi exclusion principle, which prevents two fermions from being in the same quantum state at the same time. The Fermi exclusion principle is essentially a force of infinite magnitude. Fermions can't be in the same state. It just cannot happen. Dr. George Christos suggests that a black hole may have become so big that it just could not accommodate all the fermions and then simply exploded. This is our Big Bang. Now, this is interesting because it also connects the two singularities of general relativity, the Big Bang and black holes. Furthermore, If our universe is an exploding black hole, then this would explain why there is no need for a starting point, a t equals 0. It was all there before. We, our universe, pre-existed within a bigger universe, and that universe could have been an exploding black hole in an even bigger universe ad infinitum. And if our universe is an exploding black hole and exists within a much larger universe, then this would explain inflation without the need for dark energy. The increasing rate of expansion of our universe, as we see it, is because there is a lot of matter outside of our observable universe, which is pulling it outwards by gravity alone. There is no need for a fifth hypothetical anti-gravitational force. Another idea that Dr. Christophs has put forward is that maybe our universe or space-time is just a small bubble within a much bigger space-time. So big that we cannot even fathom it. And this bigger space-time consists of lots of other universes, which all act upon each other gravitationally, causing them to all inflate, with no need for the hypothetical dark energy. Well, that brings us to the end of the video. Many thanks to Dr. George Christos for his great ideas here. Thank you for watching.